Welcome, everyone, to the Ecopsychology Café. Hello, my name is Carol Koziel, and I'm the founder of the Canadian Ecopsychology Network, the host of this series. Monica Dragos and I co-created this program. Today, we'll be in conversation with professional astronomer Dr. Travis Rector. But before we start, I'd like to acknowledge that I live in the traditional territory of the ancestral and unceded territory of the Mi'kmaq people under the treaties of peace and friendship. And I invite all of us to take a moment to remember the traditional territories we reside in various parts of our interconnected world. So, Dr. Travis Rector is a professor of physics and astronomy at the University of Alaska Anchorage. His primary research focus is on star formation, but he is also an advocate for climate education and solutions. He is a co-founder of Astronomers for Planet Earth and a co-author of the new book, Climate Change for Astronomers. Thank you, Travis, for sharing your time and wisdom with us. And I'll leave you with the airwaves are yours.
Great. Thanks, Carol. Let me go ahead and share my window. Can you all see that okay? Fantastic. Okay. Well, my plan is just to talk for maybe 20, 25 minutes about what I do and how astronomy, as a professional astronomer, I came to do what I do. And then hopefully we'll have good time for good conversation after that. So I've just divided this up into different parts, mostly just to talk first about three key ways that astronomy, I think, is helpful for understanding the climate crisis. And then if there's time, I also wanted to talk a little bit about how I talk about climate change as well. So first off, I just want to start with the story of three planets in our solar system, that of Venus, Earth, and Mars. You can actually see Venus if you go out shortly after sunset. It would be this beautifully bright object on the western horizon. It's moving away quickly, so there's not much time left to see it, but you can actually see Venus up in the night sky right now. And you can also see Mars, and I'll talk about that in a second. But Venus is often the first place that, as an astronomer, I talk about climate change. Venus is often described as the Earth's sister planet. It's almost the same size as the Earth, and it's a little bit closer to the Sun, but that's really where the similarities change. Venus is a raging furnace. It is over 880 degrees Fahrenheit, which is about, I think, 400 degrees Celsius. And the reason why it's so hot is that it has a thick atmosphere made almost entirely of carbon dioxide. And actually, Venus is the reason why I first started teaching about climate change. When I was teaching about the planets in my introductory solar system astronomy class here at UAA, many students would ask me, is the Earth going to turn into Venus? Is that what climate change is doing to us? And well, the short answer is no, we're not going to turn into Venus, not anytime soon. That that question I could answer, but then students had questions like, well, what is going to happen to the Earth and how at risk are we? And that really started my journey towards talking and teaching about climate change to help people understand the problem. So why is Venus so hot? Well, the primary reason is that it didn't develop oceans the way Earth did. Earth developed oceans which absorbed the carbon dioxide produced by volcanic activity, where Venus didn't have this, and so this carbon dioxide just accumulated and it got hotter and hotter. Now, at the other end of the spectrum is the planet Mars. Mars right now is in what's called the winter hexagon, and it's actually located now in the constellation of Gemini, so you can see both Venus and Mars if you go out on a clear night. And Mars is really the opposite extreme. Mars is turned into this cold and desolate world. Mars used to have water on its surface, so we know that it was once much warmer. And wherever there's liquid waters, astronomers get excited about the potential for life. But Mars lost its atmosphere many billions of years ago, most of its atmosphere, and as a result, it has turned into a cold, dry, and light, as we think, lifeless world. And Mars serves as a good example of a planet that could have been suitable for life and maybe once did, but those conditions no longer exist. And it's just a good reminder that planets don't necessarily stay habitable. The geologic history of the Earth also tells us a lot that can help us understand our current situation. The Earth, as it is now, is actually just been for a very short period of time. The climate of the Earth has changed a lot over the history of the years, and I promise you this is the only plot that I'm going to show in my entire talk, but it's a really powerful one. I use it a lot, and I actually used it with my students just the other day, and I think it's a very important one to understand. What this plot here shows is how much carbon dioxide is naturally in the Earth's atmosphere going back over the last 800,000 years or so. So we are on the right side of the plot, and 800,000 years ago is on the left side. And what I want you to notice here is that the amount of carbon dioxide in the Earth's atmosphere naturally goes up and down between roughly about 200 to 300 parts per million. Also shown on this plot, shown in a red line, shows how the temperature has changed during that time as well. And you can see that there's a very close relationship between how much carbon dioxide is in the atmosphere and how warm the Earth is. The more carbon dioxide there is, the warmer the Earth has been. And so this right here shows what's called natural climate change. This is how the Earth's climate changes without human intervention over the timescales of thousands to hundreds of thousands of years. Well, why does this happen? Well, it actually has an astronomical origin. It has to do with how the Earth orbits around the sun, and these are known as Milankovitch cycles. And there's actually three parts to it. The first part is the tilt of the Earth's axis. You may have learned in an introductory astronomy class that the Earth's axis is tilted, and that's what causes the seasons. The more the Earth's axis is tilted, the more extreme the seasons are. That is, the colder the winters and the warmer the summers. Now, this tilt changes slightly over time, and the Earth's orbit around the sun also changes slightly over time. This is known as eccentricity, or how elliptical the Earth's orbit is. Because of the gravitational pull of Jupiter, sometimes the Earth's orbit is stretched out into more of an egg-shaped orbit, and that changes how close this Earth is to the sun and also how long the seasons are. And then the third part of the puzzle is what's known as axial precession. You may have seen this if you've ever seen a spinning top, how it twists as it spins. And the Earth does this as well. And this changes the direction of the Earth's axis. And this changes when the seasons actually occur in the Earth's orbit. Now, all three of these combine together to produce a 100,000-year cycle where the Earth goes back and forth between warmer periods, known as interglacial periods, and then colder periods that are known as ice ages. And this plot right here, I've added two things to it. The first is when did the first humans appear? Humans appeared somewhere between 200 to 400,000 years ago, Homo sapiens as we are now. And so what that means is that humans have lived through at least one ice age. And currently, humanity is in a warmer period known as the Holocene, which has been over the last 10,000 years. And this Holocene also corresponds with the rise of agriculture and civilization and basically life as we know it now. So one of the things I like to emphasize with people is the Earth as we experience it has only been this way for the last 10,000 years or so. So in this plot, you can see how the Earth's climate varies naturally because of these Milankovitch cycles, and how the amount of carbon dioxide in the Earth's atmosphere also varies naturally between 200 and 300 parts per million. But here's where the Earth is now. We have spiked the amount of carbon dioxide in the Earth's atmosphere to over 420 parts per million in just the last 100 years. And so again, the Earth's climate changes naturally between 200 and 300, and that's over the scales of hundreds of thousands of years. But in the last 100 years, we have spiked it over to 400. And the reason why I show this visual is to make it very clear the difference between natural changes in the Earth's climate and the unnatural changes that we are causing by the use of fossil fuels. If we look back into the geologic history of the Earth even further, we can look at the fossil records, and this tells us about the history of life on the Earth. And I'm not a geologist, and I won't pretend to be able to pronounce the names of all these different periods in the Earth's history, but there are several interesting events that have occurred where there have been mass extinction events. And if we look in the fossil records, we can see there were at least five major times in the Earth's history where some event caused a great die-off. And so the white lines here show the locations in history when these occurred. And the percentage shows what percentage of species were went extinct or were wiped out during that time. And so you can see, for example, the third one there, between the Paleozoic and the Mesozoic, 96% of the species on Earth were wiped out. Now, each one of these causes was for a different reason, but the key element that combines them all together, and the reason for the mass die-off, is there was a very rapid change in the Earth's climate. And that rapid change happened too quickly for most species to be able to adapt and to survive to it. Now, obviously, all of these happen for natural reasons, but it is a clear reminder that rapid changes to the Earth's climate has catastrophic effects. And in fact, the sixth mass extinction is happening. Well, I'll get to that in a second, but I wanted to mention that the most recent one, which happened 62 million years ago, was because an asteroid hit the Earth off the Yucatan Peninsula in Mexico, and that actually led to the demise of the dinosaurs and the rise of mammals and created life as it is now. Now, the sixth extinction event is happening right now, and we're moving into a phase that many scientists call the Anthropocene, which is to say that human behavior is the primary driver for the change in the Earth's climate. Not only climate change, but deforestation and other factors as well. And currently, the Earth is experiencing a mass extinction event where species are going extinct at about 1,000 times the rate they naturally would. And this is being, again, driven by human activity. So it's just, again, a reminder that the planet doesn't necessarily and won't necessarily stay habitable for not only humans, but the plants and animals that we rely upon. The next thing I wanted to talk about, lesson for astronomy, is extrasolar planets. If you look in the news, you often hear stories about scientists, astronomers discovering planets orbiting around other stars. I'm old enough to remember when the first planet was discovered around a star outside our solar system. That happened back in 1992. And now we know of over 5,000 planets orbiting around other stars. And these discoveries have been really, truly incredible because we've been able to learn all sorts of things about them, not only their size and what they're made of and things like that, but it also helps us to put together an idea of what these worlds might look like. And one of the ideas that scientists talk about often when discussing exoplanets is this idea of what's called a habitable zone. This is a distance that a planet can be from its star, and there's the possibility that liquid water could exist on its surface. And so if we look at our own solar system, we can see this with the case of Venus, Earth, and Mars. Venus is too close to the sun and was too hot for oceans to develop, and Mars was too far away and was too cold. And so the Earth in our solar system currently is the only planet in this habitable zone. Now, unfortunately, the word habitable zone implies that these planets are habitable, where all it really means is that there is the possibility that liquid water could exist on the surface of the planet. But again, it's no guarantee that it is. So when it comes to Earth-like planets, scientists often talk about Earth-like planets, but really what we're referring to are planets that are the size of the Earth. We don't necessarily know what they're like. And so one of the things that people often think of when they hear these exoplanets is maybe there's another Earth-like planet out there that we could possibly move to if things get really bad here. But it's very important to know that outside of the Earth, we know of no planets with liquid water, no planets with an oxygen atmosphere, no planets with life, and no planets where we can live. And even if we were to discover one, it would be so far away that it would be impossible for us to get a single person there, much less that all of humanity. And as Neil deGrasse Tyson once said, if we had the technology to be able to take another planet and make it habitable for the Earth, then we would have the technology to turn the Earth back into the Earth. And so the idea that we could go live on another planet is just not realistic at all. We're much better off taking care of the one good planet that we already know of. Finally, when it comes to astronomy, I want to talk about something called the overview effect, or we astronomers call it the astronomer's perspective. And that is the perspective that people get when they see the Earth from afar. It's something that just about every astronaut has experienced when they've gone off into space. And the Apollo astronauts in particular had a profound sense of the overview effect because they flew away from the Earth as they went to the moon. And all of them had profound things to say. So here are some of my favorite quotes. Here is Neil Armstrong, of course, the first person to walk on the moon. He said, suddenly struck me that that tiny pea, pretty and blue, was the Earth. I put up my thumb and shut one eye, and my thumb blotted out the planet Earth. I didn't feel like a giant. I felt very, very small. The emphasis there at the end for myself. Another one that I really love is from Jim Irwin, who was the commander of Apollo 15. He noted that as they moved further and further away from the Earth, that the beautiful warm Earth looked like an object so fragile and delicate that if you touched it with a finger, it would crumble and fall apart. And I love this. He says, seeing this has to change a man. There's no way you can't be affected by this. More recently, you may have heard that in 2022, the actor William Shatner, who, of course, played Captain Kirk in Star Trek, got to go up into space. And he was profoundly affected by it. He talked about after he returned, he just wept and wept. And he said that when he was in space, he saw two things. He saw the death that was in space and the life force that was coming from the Earth. One side was death, and the other side was life. And I think perhaps the most profound example of the overview effect came from this little guy. Was called the Voyager 1 spacecraft, which is one of four spacecraft that NASA, actually five now, that NASA has launched out into space that have left our solar system. And the last thing that the Voyager 1 spacecraft did with this camera before turning it off was taking a snapshot of the Earth from afar. And here is the picture that it saw. So if you look closely, you'll see at the center there, there's a little white dot, and that dot is the Earth. This is what the Earth looks like when seen from far outside of our solar system. And I want to just read to you what Carl Sagan said when he revealed this image. So he said, look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you've ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother, father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all the generals and emperors, so that in a glory of triumph, they could become the momentary masters of a fraction of this dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturing, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in this great enveloping cosmic dark. In our obscurity, in all this vastness, there's no hint that will help come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There's nowhere else, at least in the near future, to which our species could migrate. Visit, yes, settle, not yet. Like it or not, for the moment, the Earth is where we make our stand. And here's the part I like the best. It has been said that astronomy is a humbling and character building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish this pale blue dot, the only home we've ever known. Now, I will say one thing, though, and this is maybe an area where I disagree with Carl Sagan. We are a special species. We have the ability to recognize where we stand in the universe in a way that no other species on Earth ever has and maybe never will again. And the ability for us to understand the universe in which we live in really is quite a profound thing. And one of the biggest transitions that our species now needs to make is understanding where we stand in the universe and the role that we can play in transitioning from a self-centered little dot in the universe to looking beyond it. And that is the hope that encourages me for us as we move into the future. Okay, so what I'd like to do now is just maybe talk a few minutes about how I talk about climate change, which I do all the time. So first off, I wanted to share with you some quotes from my students. I teach climate change in all the classes that I do. And I ask my students to ask me questions about astronomy. And these are some of the questions my students asked me last semester. First one here was, my question is how much can a few degrees really affect the world? So here's a student who's expressing a lack of understanding about why we should even care. Another student asked me, will solar panels be able to undo the negative environmental effects of mining for the material used to create the panels, or is it a losing battle? And to me, this shows a student who has been exposed to, as we talked about last month, the misinformation and disinformation that is rampant when it comes to talking about solutions to climate change. And then this student right here said, this seems like such an insurmountable issue. Is it even possible to bring the whole world together to solve this before it's too late? And it reveals, I think, a student who has a mindset of one, maybe it's too late, maybe it's hopeless, which is known as climate doomerism, but also a mindset of either we win or we lose, we succeed or we fail. It's either black or white. Whereas, of course, with climate change, it really is literally a matter of degree. And so one of my challenges as an instructor and also as a public speaker is to help counter these narratives and to help people see what we can do and how we can be successful. So what do I do? Well, if you'll pardon the pun, one of my goals is to create space. So often when I introduce myself to people, they say, well, what do you do for a living? I say, well, I'm an astronomer who's focusing on working for solutions on climate change. And people often kind of look at me strangely, like, really? Astronomy? What does that have to do with climate change? And it opens the door to having a conversation about climate change in a way that's different than maybe they've had before. And I find this often an effective way to disarm people from the traditional narratives of what needs to be done and why we should even care. And so I encourage everyone to find that way that you too can create new ways to have conversations. Most importantly, though, the most thing I do is try to be kind. As the cliche says, people won't remember what you taught them, but they'll remember how you made them feel. And it's very important for us all to keep in mind that as we have conversations with people about climate change, no matter how they feel about it, they are human beings. And many of those human beings are people who are otherwise wonderful people who unfortunately have been misled about what's happening with climate change. And one of the things that I try to do with everyone I talk about is just to have them feel like they were heard and they were respected. And even if I don't agree with them on some things, that they had a conversation with me that they would be willing to have again. And for some people, that can open the door to further conversation. And for others, maybe it's just an opportunity to increase engagement on something that they're concerned about, and maybe to decrease resistance on a topic that they don't want to talk about for whatever reason. And especially with my students, one of the things I try to do is to create hope. There's been several studies out recently that show that young generations are very anxious about what their future holds, in particular when it comes to climate change. One I saw recently said that 75% of the youth today find their future frightening. I've had students tell me that they don't want to have children because they feel like the world ahead is not going to be one worth living in. And that's just a horrible thought to think that they have already decided there's nothing worth fighting for. And how do we do that? Well, part of it is to talk solutions. What is the way out and what is happening already? What is the good news out there that often doesn't make the news and how can they be part of it? I love to share local solutions. So, for example, here in Alaska, Kodiak Island has switched to 100% renewable energy. And as a result, they actually pay less for electricity than we do here in Anchorage. And so it's a win-win scenario. They pay less for electricity, the local economy has grown, and they're also addressing climate change. And I love sharing global solutions. If you're not familiar with Drawdown, it's Project Drawdown. It's a wonderful organization and they have a great resource of all the different cool solutions that are out there. And I encourage my students to look at the website. I give them an assignment to look at the website and find a solution that interests them. Could be things like wind and solar or electric cars, but it's often cool things that maybe they haven't heard of before, like restorative farming techniques and things like that. I also like to share success stories. For those of us who are older, we remember many of the horrible things that we've experienced. I like to talk about the 1970s, which, in my humble opinion, was the greatest decade in the history of music, but was not the greatest decade for just about everything else. And there's all sorts of examples of where we have found that we were damaging the world and we changed the way how we did things, whether it be DDT with Silent Spring, the ozone layer with chlorofluorocarbons. These are all examples where we have learned from our mistakes and we have undone or started to undo the damage that we did. And so it does show that it is possible. I also love to share the example of the space race, getting back to science, astronomy, and space. In 1957, uh, the United States faced a humiliating event when their first major rocket exploded on the launch pad on national television. And just in 12 years later, we launched the world's most powerful rocket and landed humanity on the moon. And so it just goes to show how quickly things can change if a community, if a country, if a world is committed to to doing the things that it needs to do. And this brings me full circle to another one of my favorite quotes from the Apollo astronauts, which was Bill Anders, who was on Apollo 8, the first mission to go out to the moon. And he said, "We came all this way to explore the moon, and the most important thing is that we discovered the Earth." And I think this photo, a famous photo called Earthrise, shows what's possible, the awakening that can occur in people when they do have this astronomical perspective. This photo has often been cited as one of the most influential photographs in history, and in particular, started the environmental movement in the United States and the world throughout. So finally, I'll just leave you. As Carol mentioned, I am one of the co-founders of an organization called Astronomers for Planet Earth, where we have professional and amateur astronomers who are working to bring our knowledge to people to help them understand the climate crisis. And I'll also mention that I've recently co-authored a book called Climate Change for Astronomers. And while the book is intended primarily to help my fellow astronomers and understand the role they can play, there's actually quite a few chapters in there about effective communication strategies, about the psychology and sociology of climate change, and there's a link right there where people can download a PDF as a preview copy and see if there's anything there that interests you. The two chapters I think are most interesting are ones that I co-wrote with a journalism and public communication professor, where we talk about how are the best ways you can communicate about climate change, and what is the other forms of communication that are going on out there that people need to be aware of. So there's the link to it, and you're more than welcome to check it out. And with that, I will end and be more than happy to answer questions or open it up to whatever conversation you'd like to have.
Thank you so much, Travis. That was an excellent presentation. I learned so much.
Thank you.
And I feel hopeful. I feel hopeful that your field is working towards our big problems here. So yes, thank you.
Appreciate that.
Jennifer Nathan says fabulous. Thank you so much. Great.
You're welcome.
Anybody have any questions or comments for Travis?
I have a very general question that just kind of came up during your presentation. Some years ago, I was listening to Brian Swim give a presentation, and he was talking about um, that sometimes when he's teaching, he called it space-time sickness comes up for people, where it's so disorienting to take in the vastness of the universe that they have almost a reaction where it makes them depressed. And I was just curious about the range of reactions maybe you've heard from students over the years. Um, like I think you had some really inspiring quotes, and I wonder, does it ever go the other way where people do feel small, but not in that good way, not in that
Sometimes, yeah. I mean, astronomy is accused of trying to make us feel bad about ourselves, right? We learn that we're not the center, we're not the center of our solar system, we're not the center of our galaxy or the universe, and maybe we're rather mundane, but it's really quite the opposite. I mean, the one thing I really do want my students to take away is just how fantastically rare and special the Earth is, that the Earth has maintained life on it for over 4 billion years when other planets have failed. And I didn't have time to talk about it today, but there's this famous example, what's called the Fermi paradox, which is to say that if advanced life is possible, where is it? Why aren't we seeing signs of it all over the universe? And there's many possible solutions to the Fermi paradox, but the mere fact that we don't see it tells us that life like ours is very rare and special, and it's something to be cherished and to be protected. Um, I would like people to have maybe the same sense that William Shatner had, that the universe is an amazing place, but also a dangerous place, and it's not a place that we can survive. Uh, the furthest humanity has ever traveled from the Earth is out to the moon, and the moon in light travel time is 1 light second away from us, whereas Mars is about at its closest is 4 light minutes, and the nearest stars to us are 4 light years away. And so, if you compare a second to 4 minutes to 4 years, it gives you a little bit of a sense of that scale. And I hope that that gives it, maybe a little bit of fear in people, but also I think maybe an inspiration as to why we have to take the Earth as seriously as we do. One of the things that William Shatner mentioned that really struck him was how thin the Earth's atmosphere is, how thin that shield that gives us life. If you took a 1 foot globe of the Earth, the standard globe we have in our classrooms, the Earth's atmosphere would be as thick as a sheet of paper on that. And so when you see it from above, it really gives you a sense of just how fragile the Earth truly is. And so getting back to your question, Monica, are my students depressed by it? I don't think so. I think hopefully they're inspired by it.
thank you.
And you have a question or
Yeah,
comment?
thanks very much. That was a really great presentation. I'm sponging a lot here. Just I have a couple of questions. One, the could you just give the figure for the rate of extinction within the Anthropocene? The actual figure?
The rate is roughly about 1,000 times what it is naturally.
Right. Okay.
Yeah. I mean, I don't remember exactly what the units are as far as
Okay.
how many species, but it is far higher than it naturally is. And that's not just climate change, it's also loss of habitat, deforestation, air pollution, and water pollution, things like that. But it really is all as a result of how humans are affecting the earth. And again, I think that's a really important transition that people need to make. We tend to see the earth as this infinite resource that can provide everything that we need, and it really isn't. And we are now at the point where we are changing the earth in ways that we just didn't think possible. And you do see some people say things like that, like humans can't change the earth, but clearly we can, and clearly we do. And so understanding how we're affecting the earth and how that affects the habitability of the earth for us is, I think, one of the fundamental transitions in us as a species, being able to see ourselves as being earthlings, that is, inhabitants of this planet rather than just people.
Yeah, great. Yeah, the other thoughts I had or questions I had around like I guess it's Monica's question and also the overview effect and just how significant that is or can be. And I guess I am personally wired for the fascination of the universe and everything we can glean from that perspective. But I do know people, and I was trying to think if they were a particular demographic or but who can't go there. And like it's sort of nauseating or overwhelming or I think maybe overwhelming is the consistent feature. So I was just curious about that and in terms of how to link that, like through your students, is very interesting. And also, you referred to in your most recent textbook, I guess, or book about linking with, did I understand correctly, a journalist or someone who's communicating maybe to a broader spectrum of people in public communications, and how does that work, I guess?
Yeah, so I mean, one of the things that I think is very, and again, the book is written for scientists, but it's at a level anyone can read. So please feel free to dive in. The most important message I wanted my fellow scientists to hear is that we often beat ourselves up. Like, well, we've been yelling for years about climate change. Why aren't people listening to us? Why aren't people taking it seriously? And scientists often have this mindset. It's not called the knowledge deficit model, and that is the assumption that if you teach someone something, once they have that knowledge, then they will naturally know how to respond to it. And so we've often assumed, well, if we just explain to people what's causing climate change and the consequences of it, why it's a serious problem, then people naturally take the actions that they need to do to stop it. And that doesn't work for a variety of reasons. One is that it's not obvious what the solution is. I mean, on one hand, you can say, yes, 90% of climate change is from the use of fossil fuels, so we need to stop using them. But that's easier said than done, right? How do we transition our all of our energy sources to other sources? The other factor is that, and this is what wrote about with my journalist colleague, is that there's all these other sources of information about climate change that are going out there. So people aren't just hearing from scientists, they're also hearing about it in the news, they're hearing about it on social media, from friends and other trusted sources. And those groups and organizations and individuals can often have much greater influence. And so you may hear from a scientist that it's a serious problem, but then you may hear from a friend who says, it's just a bunch of bunk, right? Or, I have a friend who said they're all lying or that sort of thing. And so we often and this was really shocking for me to learn, was just the extent of the campaigns of misinformation and disinformation that exist out there. And a lot of this was discussed last month, just how much misinformation is out there and how effectively it's spread. So, for example, with electric vehicles, there's all sorts of falsehoods about them spreading as far as that they're worse, that the mining for them is worse for the environment, that they catch on fire, that they have no range, et cetera, et cetera, et cetera. And I'm not going to pretend that electric vehicles are perfect. No solution is perfect. But the fact that this information spreads so rapidly and has been so effective in confusing people about what to do, that has stalled the adoption of electric vehicles. But the flip side of that is that if you meet someone who has an electric car and they tell you, hey, this, I love it. It's a wonderful vehicle. It does everything I need. It does great in winters. I've had no problems with charging or range, et cetera, et cetera. Then you're getting information from a trusted source, and that can be really influential. And so that's why conversation about climate change is so important, whether it be, the causes or the solutions. Even just saying, I care about climate change, that normalizes concern about it. If you buy an electric car, that normalizes electric vehicles. If you get solar panels in your house, that normalizes that as well. And so, I'm totally rambling at this point, but I'll just say that those are the most important factors in deciding how people feel about things. This is their trusted sources. And my hope is that I can be an educator and I can be a trusted source, but I can also help other people be trusted sources as well.
Thanks so much.
Peggy, you raised your hand?
Yes, I'm actually quite shocked that to hear that astronomers and so on have come to the conclusion that it's not likely there's life on other planets. But I'm wondering, like that's very shocking. I really didn't know that. Isn't there sort of a mathematical probability that there would be life on some planet somewhere?
So yeah, so I apologize if I gave that misconception. So first
Oh,
off, we is there life out in the universe? Undoubtedly.
oh,
Um, So, I mean, if you just look at the sheer number of stars in a galaxy and the number of planets in a galaxy and the number of galaxies in the universe, I mean, it's estimated that there are over 1 billion planets in our galaxy alone, and there are hundreds of billions of galaxies in our observable universe. So there's most definitely life out there. Now, did that life evolve to be an advanced civilization, into advanced civilizations like ourselves? That's extremely rare. I mean, if we
mm,
just simply look at the Earth's geologic history, it took us 4.5 billion years to get to where we are now, and only one species has achieved what we have as far as the ability to develop technology to communicate beyond the Earth. But also for humans, we've only had that ability for 100 years. I mean, you
mm,
think about how much human civilization has changed in the last 100 years. And one of the things I like to do is challenge my students. What do you think the Earth's going to look like in 100 years from now? What will civilization be like? What about 1,000 years? What about 100,000 years? What about 1 million years? And so one of the big question marks is how long do advanced civilizations last? And are they able to last long enough where they can be abundant in the universe? Because the 100 years where our species has been a quote unquote advanced civilization is an incredibly small fraction of time compared to the overall history of the universe. So the Fermi paradox asks, well, why haven't we heard from advanced alien life? Why don't we see any signs that it exists? And we know from that it's extremely rare. And if it does exist, it must be quite far away and hard to detect. So do I think life is out there? Absolutely. Do I think there's advanced alien life out there? Absolutely. But I also think it's very far away. I don't think it's likely we will ever detect an advanced alien civilization, though it would be absolutely amazing if we did. And I, of course, also don't think that UFOs have, landed on Earth and done things like that. I don't think aliens have actually visited the Earth. It's just simply too hard to do. We would be able to detect them otherwise. So, is life out there? Absolutely. But just the fact that we don't hear from them does show us that it's quite rare. And again, that humans are quite special.
Yeah, and who's to say an advanced civilization would be interested in that kind of mobility? That is sort of a pre-assumption that they would want to build a spaceship and start traveling all around all the galaxies. Who knows what their, you know, psyche would even involve that kind of interest to go traveling. So there's a
Hmm.
lot of unknowns about what a civilization somewhere else would be like. We really have no clue.
Yeah, that's a good point. And that's one of the things we have to be careful about is what assumptions we make
Mhm.
about what another advanced civilization might look like, as
Yeah,
far as what kind of behavior they would engage in. Would they be as competitive as we are? Would they be as warlike as we are? It's hard to say. And so, I mean, even here on Earth, of course, there are advanced, intelligent forms of life, uh, but they don't have these guys right here, so they're not able to build telescopes or rockets or weapons or things in the way that we do. So those are all we always have to be very careful about what conclusions we draw from what has happened on the Earth, because the Earth is just one example. And and that's a big part of why we're interested in discovering so many different other planets, is to see whether or not the Earth is typical or if it's extremely rare. And we don't have an answer to that yet.
wonderful. Thank you. Wow.
Jennifer, do you have a question before we wrap up?
Um, just the link between astronomy and climate change is so much bigger than like Carl Sagan now I see all over the place. So he's been one of the biggest quoters of kind of figuring out how we're doing on Earth because of that perspective, I think is so amazing. And yeah, I was at a conference in Pasadena when the lander opened up and shot back live pictures ish of Mars. And everyone's crying and cheering. And I was sort of crying, but not because of how amazing this technological achievement was, but on how barren and unfriendly Mars looked and how fragile and beautiful Earth is. And yet people seem to be more obsessed with going to Mars than working on our own planet. So I loved your talk about kind of we go out so that we can look back and see how just amazing our planet is. And yeah, that's a really interesting question to try and get us to look ahead to see where we're going on Earth. What are we going to look like if we continue this pathway? How can we sustain ourselves? Yeah, so I'm curious as to how it would look if we were to change our path to be more sustainable. What do you see the planet looking like in 200 years, say? Which is only really, a couple of generations, three, away.
Well, I wouldn't even begin to know how to answer that question, but I do challenge my students to do that. One of my colleagues, a fellow astronomer named Jeff Bennett, he does a wonderful thing where he asks his students, "What do you think the world will look like once we've solved climate change?" And I think that's a real profound moment. We don't even ever hear or think about a world past this.
Mm-hmm.
And, for those of us old enough to remember the Cold War and, the horrible air pollution we had in the 70s, again, the greatest decade for music, not the greatest decade for just about everything else. Well, there's a lot that we have been through and have survived. And I'm not worried about humanity going extinct. I don't think that's going to happen, but I do think, unfortunately, there's going to be a lot of suffering between now and what that future is going to look like. And I feel it's our obligation to change that, to minimize that suffering, and to help us transition to, frankly, a world that everyone is going to want to live in. We tend to see things as a zero-sum game of winners and losers. And what if we had a world where everyone could have the energy they needed and the food and water they needed? I mean, these are all things that everyone can, does, and should want. It's just often not clear how to get there. And so, you mentioned before about Mars. Students often ask me, what's my favorite planet? And I always say it's Earth. I mean, have
Yeah.
you looked at the other ones? I mean, Saturn's got rings. That'd be pretty cool. I kind of wish we had rings, though it would be catastrophic if we did. But you don't have to look very far to see that the Earth really is spectacular and amazing. And if you were an alien civilization coming to our solar system, you'd just go straight to the Earth. You would skip everything else. Earth is
Wow.
clearly the coolest place of them all, and we just have to keep that perspective.
Wow, thank you so much. I was going to ask a quick question, but maybe I'll leave it as something for us to ponder as eco-psychologists and ecotherapists and nature people who are involved in the nature connection movement. I invite everyone to get outside and connect with the more than human world up in the sky as one way to catalyze some climate conversations. So, thank you so much, Travis. What a juicy talk. Great.
I will say that, and that was really kind of the last thing I wanted to say to wrap things up. The night sky is a great source of comfort for me to be able to look up and see Venus and Mars and the moon and just the clockwork of the universe, the constellations as they change throughout the night sky. Um, I find the universe to be a great source of comfort. And so I encourage everyone to look up, look and see what's going on. If you can get familiar with the night sky, the motions of the stars and the planets, it really is a world that is, I think, amazing and helps us. I, I think helps me to put into perspective the issues that we face down here.
Thank you so much. I'll end our recording.